Welcome back to the Student Hub Live STEM Showcase. We are talking about waste management, recycling and plastics in this session. And I am joined by Tony Gladding and Carl Boardman. Now, you both do really interesting things. I'm going to tell everyone what you do. Tony, you're a senior lecturer in environmental engineering and you carry out research in air quality of downwind biological waste management treatment facilities.
I do.
But you're talking more generally here about waste management and the recycling of various materials. And Carl, I love the sound of some of the things you're doing, and it's so topical right now. You're a lecturer in engineering and environmental sciences, and you've just done a research project looking at the biodegradability of various plastics, including fossil fuel derived plastics and bio-alternatives. So that's really interesting because plastics in the environment is so topical right now. I think, you know, after Blue Planet, we all were absolutely horrified. But it's a continuing issue, and so I'm very interested to see what your research is all about. And you brought some plastic today.
We have. I think the important thing to remember about plastic is it's necessary. Single-use plastics are pretty much all of our food packaging. So it's not like we can suddenly decide we're not using plastics overnight. It's a very cheap way of getting your food to you freshly. So it's one of those things we can't do without. Having said that, there are perhaps some changes that could be made.
But we didn't have them a long time ago.
We didn't, but we had things like paper and card, and which basically cost a lot more money to produce and aren't as hardy, and all the rest of it. So unfortunately, plastics are probably here to stay. The issue is dealing with them once we've finished using them.
So there's this increasing trade-off, I guess, as we get more technologically advanced. The world population gets bigger. There are more mouths to feed. Producing and transporting food and products, etc., becomes more meaningful, and so plastics are a key part of that.
Yeah, I mean, we've got a growing population, we've got a growing food production. In the UK alone, we use something like 13 billion plastic bottles every year, something like 8 billion straws. You know, we're talking a lot of plastic waste, basically.
Yeah. And a while ago, I can't remember how long actually, it probably shows my age, but we became increasingly aware. You've got some of the recycling bags, and I live in West Wales and we have a very good recycling facility in my area. Over the road, not so good. So things are very varied. And one of the questions we've asked our audience is how much they think they pay for waste management in their council tax. And also we've asked you at home how long you think a plastic bottle lasts in the ocean. So do select those items. Just click on the widget that you want to reply to, which is the interactive voting tool. Select the option you think is best, and then you'll see what everyone else has said as well.
Good. So yeah, I mean, in the UK, if we talk about the UK first, then we can go on and reflect a bit further around the world. In the UK alone, we produce around 200 million tonnes of waste per annum. That's a lot of tonnage.
What does that look like? That sounds so nebulous.
It's huge, basically. When you think there are something like 400 facilities dealing with it, it's almost unimaginable. It's very difficult to visualise. But if we were talking about the plastics component, well, there's two components that might be of interest actually. Of that 200 million tonnes, only 27 million tonnes is household waste. Right. So the rest is construction, industrial, mineral, dredging, all that kind of thing. So household waste is actually quite a small percentage of the overall waste production. And of that 27 million tonnes, about 0.5% is plastic. There's all sorts of packaging, because you've got to remember there's glass and cardboard and paper. They're all types of packaging. But plastics is around 0.5%. So all in all, about 1 million tonnes per annum at most from the UK. There's something like 8 million tonnes per annum that's actually exhausted into the oceans around the world. So, the UK is actually a developed country. We have a very good waste management system. We recycle about 44% of our plastics, but there are problems with recycling, which is why we've brought some examples today.
So do you want to see what people said at home about how much they think they pay for their waste management and their council tax? Right, let's take a look at what you said. So here we've got 44% in the lead with 25%. No one has thought 50, 33% think 10%, and 22 think 1%. Yeah,
so nationally the correct figure is around 10%.
Wow.
So only 10% of your council tax actually deals with everything from your waste collection to taking it to a facility to the treatment. to removal of any waste to landfill, you know, that everything. It covers absolutely everything.
And the interesting thing here is that people thought it was 100% more than it actually is.
Yeah.
And I guess that's part of the question about, well, what is council tax for anyway? And a large part of what we see is waste collection in terms of, you know, being an average consumer.
Yeah.
Why is that question important?
It's important because I think people think that, well, they get there's a lot of publicity around weekly collection of waste. And people think I've paid for this in my council tax, but they don't realise that actually only a very small proportion of their council tax covers that. And if we move to things like fortnightly collection, which is a little controversial and lots of people don't like it, it's actually been proven that it's the only way we can actually raise our recycling rates, because basically then people do recycle if they have a less frequent waste collection.
We had a change in our recycling where I live, and they have a fortnightly black bin collection, which is all your sort of non-recyclable waste. And I know from my own perspective, I hardly ever use that, whereas I know I used to use it a lot before. I'd say it's had a massive change because I know I can get rid of things. If I just wash them out, I can recycle my plastics. And I think we're more aware of them. So are changes like that really impacting on behaviour?
Absolutely. I mean, it's pretty clear from all the stats that when a local authority moves to a fortnightly or less frequent residual waste collection, that their recycling rates rise.
Now, we all care about the environment, and I think so many people are very mindful of it. So many people often think, well, there's nothing I can do to change the situation of the world, you know. But actually, waste management is one thing that you can have a very, you know, real impact on. So why might people not be agreeing with that whole idea then?
Well, I mean, it's not necessarily that they might not agree. Different councils operate different systems. So in Wales, they have kind of more of a unitary approach to it. Hence, we see higher recycling rates. But across England, for instance, you know, different councils operate in different schemes. So it's actually genuinely quite confusing. So people that want to opt into these systems and participate are finding it really quite hard, struggling with, you know, all the bins that they have to put their stuff in.
Yeah.
So, you know, there is people that want to, but, you know, can't. Other than that, I guess if it's easy just to throw it away and there are no penalties as such, then you might find a few people that want to do that, yeah. So.
When I lived in New Zealand, which was a long time ago, they had already started to limit how many bins you were allowed to put out, and there were that whole idea of penalties also. The plastic going into the ocean, you know, is a really topical issue. And Tony, you mentioned, you know, that there was a huge amount that was being pumped into the ocean. What can we do about that?
I think this is more.
Shall I take that one?
Yeah.
So I suppose we could start with sources really. Plastics come from many, many different sources. It's not just, you know, the bottles that we see here, for instance. That's part of it. You know, they're the big things that we can see and we visualise and we see them floating on the surfaces. But really, the plastic in the ocean, what we're really talking about is tiny, tiny, tiny small bits of plastic that you can only really see under a microscope. And they come from things like washing your clothes. They could be fibres, for instance, synthetic fibres. They can come from your tyres of your car, you know, the rubber compounds breaking off into the rivers and the gullies and channels and washing into the oceans. And they can also come from industry processes that use pelletized forms of plastic and that get washed out into the effluents. Because it's very uncommon, for instance, for companies to really filter down their effluents down to the macro and nano scale, you know, a thousandth of a millimetre scale is what we might be talking about here as well in terms of some of the plastics. So they come from all manner of sources. But I think, as Tony said earlier as well, you know, that the major source of plastic into the oceans isn't really kind of the developing world. So where they don't actually have some of the waste treatment facilities to put their recyclable content into. So it's not that they don't want to recycle, it's that they don't have the capability to actually do that. And so you see lots of rivers that are clogged up and choked with plastics which are flowing out into the oceans. So yeah, they come from all manner of places. In terms of what you do about it is a tricky one. I mean, we all live in a world where we're consumers. So there is always a penalty for being a consumer, whether that be in terms of energy or the associated emissions from processes. There is always going to be a cost. So we can change our behaviour individually. So we can try and limit the amounts of production that certain types of materials that we deem to be more impactful on the environment. So we can limit buying those. We can look at technological innovations. You know, we can look at maybe shifting from fossil fuel derived polymers and plastics more towards naturally occurring plastics, bioplastics, things that might include things like starch and lignin, which kind of break down naturally in the environment. We can look to policy. You know, we can really look to ban microbeads in plastics, which we've done in the UK recently. So there are many things you can do across a whole spectrum, from an individual all the way up to kind of corporate social responsibility, and all the way up to government level as well. And if you really are going to make an impact, then you probably need all of those levers really pulling in the same direction.
And you've mentioned, you know, with the developing countries that they don't have the infrastructure to be able to do that. And you've mentioned the various things, individual levels and policy levels. And how, you know, I guess it's a chicken and egg sort of situation, but ultimately, if there are no policies to some extent, there's no incentive or perhaps penalty, depending on how you do it.
And it's technologically different. I mean, we've got some example plastics here. For instance, this is a PET bottle, and they're PET trays, but this is something called high-density polyethylene, so you can't mix the two. So if you're recycling these, you would have to put these through different waste management treatment processes. So that's partly why, I mean, it's expensive to ship plastics because it's light. It's expensive to recycle it because they can't be mixed. So, you know, even the lids are sometimes a different material to the actual bottle. It's about 50 different types of plastic. So it's not simply, you know, you can't simply build a factory and recycle plastic. It's a you know, it's an expensive thing to do.
Which begs the question why we have so many different types. I keep going on in New Zealand, but, you know, we did used to have the milk in a sort of a packet. And everyone then bought a carton and put their milk in that. And so we didn't then have any of these milk bottles, for example. And all of the washing detergents, everything, all the plastic bottles sort of went. And, you know, it did become a lot messy, but that was just the done thing and everyone did it. That was 20 years ago. We asked everyone at home how long they think a plastic bottle lasts in the ocean. Shall we see what they said? So we've got in the lead here, 75% of people think it's 1,000 years, which is the highest number that we've had. That is a long time. Even for me. What's the correct answer?
It's more like 450 years.
Yeah.
But even though it's still in the ocean, it breaks down into smaller pieces.
Yeah.
That's the problem.
Yeah.
So it's not like, in 450 years there's no plastic anymore.
Yeah.
What actually happens is the plastic degrades because UV light will degrade it, and the wave action and all of other sorts of things. And then it just becomes smaller pieces, and they can biopersist for a very long time. So, so technically, they could go on for many more years. So, 1,000 years isn't a bad bad estimate.
No,
so,
exactly. Okay, excellent. So, what is your research, and what are you hoping to achieve by doing that?
So I look at the environmental impact of materials, so very broadly speaking. I look at how biodegradable they might be in waste management treatment processes, like composting and anaerobic digestion, but also as well how biodegradable they might be in open environments, natural environments, rivers, sediments, oceans. So I like to get a handle on, you know, different types of materials. How long are they going to be around? I also then like to look at what kind of impact they might have when they degrade. So is there any kind of ecotoxicity, any toxic effects from these materials? So plastics, for instance, are known to absorb persistent organic pollutants that kind of might be within ocean environments. So you have these things like pesticides, PCBs, which many of them have been banned for a long time, but they exist at low-level concentrations in the environment. When you have a plastic material that ends up in the oceans, I think of it kind of a bit like a sponge, a chemical sponge. It will absorb all these pollutants and concentrate them potentially up through the food chain. So that plastic piece that inadvertently a fish has consumed, it didn't want to, it's done it by accident, it might not be toxic to the fish. Okay, but if we go up the food chain, a predator eats 1,000 of those fish. Can you see how then it concentrates further and further up the food chain? So it might not be the plastic itself that has a physical kind of entanglement, detrimental effect. It might actually be the pollutants that are leaching out from the material itself, and also the persistent organic pollutants that have been residing in the environment already, leaching out after as well. So it's, in a way, it's kind of multifaceted. It really is. Once you start getting these pollutants within any kind of biological entity, they start messing around with all kinds of biological processes. They start crossing your cell membranes, they can mess around with your DNA structure, and you have all sorts of stresses and strains associated with that as well. So it can be quite problematic, and hence the kind of the focus that's been on it. So I look to basically quantify kind of as many of those steps as possible, you know, with different colleagues and friends. So, yeah, that's kind of what I like to do. And I try to work with companies as well who are looking to have more biodegradable materials and materials that are designed to be less impactful in the environment, should they be a fugitive, if you like, a fugitive plastic. It doesn't intend to go into the natural environment. It's got an end-of-life intended purpose, but through inadvertently, but catches by the wind or the process, it ends up there. And so, you know, dealing with companies that take their social responsibility seriously. So, yes, that's the difference what we're trying to make. So we're trying to understand it, we're trying to make a difference as well.
Brilliant. I'm going to ask you next, Tony, but I just want to take a trip to Teresa because people are talking about the various steps that they're taking to reduce their plastic.
That's right. I mean, there's lots and lots of conversations here. It's great. Lots about composting. Lots of big composters out there. Would like maybe some tips on composting. And there's the whole debate on single-use plastics, how we can reduce our everyday kind of use of single-use plastics. And there was a nice idea from someone about, you know, here you have the colour coding on packaging for fats, protein. Could we have something on plastics that indicated the type of plastics and how we can then recycle them? Because I think there's a lot there that could be done out in the industry and making us more aware of what plastics, and what can be recycled, which it's still a bit of a dark art, really, I think.
No, it absolutely is. I mean, my friends in London have all of these various boxes and spend all of this time sorting and categorising things. And I was watching a programme the other week and they were saying, you know, so much of the good intentions are spoilt because people don't wash things and they become contaminated, for example. So there's a lot of public education.
Yeah. It's tricky. I mean, picking up on what Teresa said there, so there's a couple of things. In terms of better labelling, there are schemes, there are European-wide schemes that promote, I think the camera can pick up this one. We have these kind of a leaf in kind of a ribbon. So there are kind of certified schemes that they will test and they will see if materials are biodegradable in compost environments. But they're not widely known. I mean, for instance, you know, my family wouldn't know what that meant at all. So, you know, but it's very tricky. I think you kind of have to understand as well, it's a business world and there are a lot of competing factions, you know, with different technologies. And so they're all kind of, you know, the elbows are out. They all want their piece of this kind of green pie, if you like. So trying to get a consensus is really tricky. And this is where sometimes, you know, an industry-led consensus is great, but sometimes you need a higher level kind of government or European kind of framework to really kind of almost force people into a harmonised kind of labelling system as well. So,
I know, it force people into a harmonised, it sounds like a juxtaposition, but...
It's tricky. I mean, you know, there are plastics out there that are compostable as well. So, you know, these are usually designed for industrial composting processes. So designed to sort of be food caddies. They take your food away, they incorporate it into the industrial processes. There are other types of plastic as well that you could put in your home composting bin, but they would typically take maybe about a year or something like that to degrade. And as well, you know, I mean, I've got compost heaps as well. You have to actually manage it. So you've got to turn that compost over. You've got to get the oxygen in there. Because basically a compost heap will use all the oxygen within kind of minutes within the core of it. So this is why you have to turn it and aerate it. So then you get lots of oxygen in there, so the microbes can break down the different types of polymers, natural and sort of synthetic as well. So yes, there's a lot there. So I mean, when you design any type of material, it's always useful to have the end of life process in mind. So there's a lot more of this kind of sort of circular economy, end of life thinking. So instead of just really designing, say, a carrier bag that can carry 10 kilos, into the design process at the beginning is, yes, we want a carrier bag that can hold 10 kilos, but we also want it to be recyclable, to be biodegradable, and this starts at the very beginning of the process.
To cook out dinner, to be attractive.
It is. I mean, you start with a wish list, you know, and you know these companies have to work down it, and they're constrained by science sometimes. You know, there's a lot of innovation out there. But still, you know, we are still looking for effectively like what would be a holy grail of plastic that could be biodegraded in the natural environment, and we're currently not there. You know, whether it's fossil fuel derived or bio-based, you know, we are not there yet. So there is a lot of scope for improvement there.
But composting is a thing that people can do at home, very easy to do, can make a real difference and can be a good use, even if it is a lot of hard work.
It requires a bit of space and a bit of technique, but it can be done. Yeah.
We're nearly out of time. Any tips on composting, Tony?
Gosh, tips on composting? No, not particularly. I'm not a gardener. Turn it, yeah.
Turn it regularly. Yeah. Turn it regularly.
I've been meaning to set up a little compost heap, but I've never quite gotten around to it. But
or get one that's on a rotatory kind of actually.
Oh, really?
Oh,
Oh,
yeah.
That's
the
a good
easiest.
tip, see?
Yeah,
Don't
the
be breaking your
easiest.
bracket back. Yeah.
Yeah, excellent. All right, well, that has been an incredibly interesting session. Thank you both so much for coming along today. And thank you, everyone, for chatting at home, to Teresa and to each other, and some great stuff going on there. We're going to show you a short video now. If you like the Faculty of STEM's Facebook page, which you can find at the Open University STEM or at Open Uni STEM, you'll see there are regular sessions on Meet Us Mondays, and we're going to show you a short video now. But again, that's a great way to meet various academics and other members of staff from around the Open University each Monday. So join us after that video, and then we're going to be talking about Students for Students. So I'll see you in about 5 minutes.